Hey everybody, Mrs. Dorosset here. So welcome back from break. Hope everybody's doing well. Let's go ahead and take a look at what we're doing next. So I'm going to review first like how we find those key points for sine and cosine. So first let's look at if we have y equals sine x, how we get those 5 key points. So the key points we always use for sine and for cosine are going to be that 0, those quadrantal angles. So those quadrantal angles are going to be that 0, pi over 2, pi, 3 pi over 2, and 2 pi. And that's just because these are the easiest ones to find the answer to. So when we look at our unit circle, if we use these values for our angle at 0 right here, the sine value is always this. Remember how it goes cosine first, sine second? So the sine at 0 is 0. At pi over 2, the sine is 1. At pi, the sine is 0. At 3 pi over 2, the sine is -1. And at 2 pi, the sine is 0. So these are the key points that we always use when we're doing sine theta. Those are the key points. The key points, if we are doing y equals cosine x, let's make our xy for this, we're still going to use that 0, pi over 2, pi, 3 pi over 2, and 2 pi. But now when we look for these cosine of these angles, so here at 0, the cosine answer, it's always going to be the first one, is 1. At pi over 2, the cosine is going to be the first one here, it's 0. At pi, cosine is going to be -1. 3 pi over 2, the cosine is 0. And at 2 pi, the cosine is 1. So these are our key points for cosine. So when I'm doing these problems, I first look, do I have sine or cosine? I know that my x's are always just going to go 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now I have to look here. I'm doing cosine. So I'm going to use these y values. 1, 0, -1, 0, 1. Now what we have to do is think, what does this do? Well, that's going to be a vertical stretch by 2. So that number right there tells us I have to multiply the y's by 2. And then this number tells me I have to go down 1. So now after I multiply, because multiplication is always done first, after I multiply the y's by 2, now I'm going to have to subtract 1 from the y's. Okay, so I'm going to do this first. I'm going to multiply all my y's by 2. So 1 times 2, 0 times 2, -2 times 2, 0 times 2, 1 times 2. And I also have to subtract 1. So now I have to do 2 minus 1, 0 minus 1, -2 minus 1, 0 minus 1, 2 minus 1. Now, here's what's new. We've already done all that. But this right here, when I have a number in front of the x, this is actually going to be what's called a horizontal shrink by the reciprocal of this. So because x is getting replaced with 2x, I'm going to have a horizontal shrink by 1/2. So what that means is all of these x's are now going to change. That hasn't happened before. But now all the x's are going to have to get shrunk by 1/2. So I have to take half of this x, half of this. So if I do half of pi over 2, I just multiply straight across. That gives me pi over 4. If I do half of pi, multiply straight across, that's going to give me pi over 2. Half of 3 pi over 2, multiply straight across, 3 pi over 4. And half of 2 pi, if I do half of 2 pi, multiply straight across, 2 pi over 2 is going to just be pi. These are now what we're going to be graphing. So when x is 0, my y is 1. when x is pi over 4 is right in between 0 and pi over 2. So right there's pi over 4. I have to plot -1. Here's pi over 2, and I have to plot -3. 3 pi over 4, 3/4 is in between a half and a whole. So to plot 3 pi over 4, that's right here in between these two, and I have to put -1. At pi, right here, I'm going to have to be at 1. And now I just continue that pattern. So halfway in between here, down, halfway in between here, and up. I can go backwards. You don't have to do the whole thing like I am. We'll stop there, that's good enough. So as long as you have, look at your roller coaster ride almost. As long as you have it graphed from here to here, like we did with these points, I'm fine with that. Okay, so what happened on this is that we had a lot of things happening. We had a vertical stretch by 2, we had a shift down of 1, and we had a horizontal shrink by a half. Let me show you how you can check this on your Desmos. If you go to Desmos and you put in y equals 2 cosine of 2x minus 1, here's the way it looks. Move it up here. Can you see these points right here? So if I click on this, it's going to tell me I have that 0.01. Remember, we had that point. I'm going to go along here. Let's find this point. See how that point's at pi over 2, -3? Remember how we had that point? It does best with the high and the low points. So like I can see this pi over 1 here. And if I look at my paper, see how I had that point pi 1, so I know it's right? Okay, that's how we can look at that. Now, the amplitude is just the number out here in front, and it's always positive, so that's 2. The domain, this goes on forever and ever. So the domain is going to be -infinity to infinity. The range, we look at our bottommost point, that's -3, up to our highest point, and that's 1. The sinusoidal axis is right here in between the high and the low. So the high's here, the low here. It's all these middle points. So we have to think, what's the equation of that line? The equation of that line is y equals -1. It's always going to be the same as this number right here. This sinusoidal axis, it can also be called the midline. So like if you take any college level trig, they might call it a midline instead of a sinusoidal axis. It's kind of easier name too. All right, let's do our last one. So we know that for x's, we always start off by using 0, pi over 2, pi, 3 pi over 2. The reason we do that is just because these are the easiest values to use because they're quadrantal. Those sine values, go to your sine values, your normal sine values here. Look at the pattern, 0, 1, 0, -1, 0. So that's what they're normally going to be, is 0, 1, 0, -1, 0. Okay, but now we have to think about what's happening. So our new y, this right here, this is going to be a multiplier of y. So we have to multiply y by 3. Let's go ahead and do that first. 0 times 3, 1 times 3, 0 times 3, -1 times 3, 0 times 3. This tells us that we now have to add 2 to y. So whatever y I got here, 0 plus 2, 3 plus 2, 0 plus 2, -3 plus 2, 0 plus 2. Okay? Now, when I replace x with a 1/2 x, that is going to be a horizontal short stretch of the reciprocal of this. So the reciprocal of 1/2 is 2. So we're going to have a horizontal stretch of 2. So I have to take all my x's. See, x's deal with horizontal. Y's deal with vertical. So I'm going to have to take this x and I'm going to have to stretch it by 2. So multiply it by 2. Pi over 2 times 2. See this? This would give us 2 pi over 2. What's 2 pi over 2? Just pi. I have to multiply this by 2. 2 times pi is 2 pi. 3 pi over 2. If I multiply that by 2, I'm going to get 3 pi. 2 pi times 2 is 4 pi. Now, look at our axis though. It goes 0 pi over 2 pi, 3 pi over 2, 2 pi. So I'm going to have to extend it. Continue the pattern out. Here's 1 pi over 2, 3 pi over 2. So this would be 5 pi over 2. After 2 pi, see this is 2 pi, this is 2.5 pi really. This is 3 pi. This is going to be 3.5 pi, or 3.5 pi is, we'll just call it 3.5 pi. It's going to be, that would be 7 pi over 2. And then here's our 4 pi. Okay, so we're just going to have to extend this a little bit, just to make it so we can graph the whole thing, because we can't graph the whole thing otherwise, because it's so stretched out horizontally. All right, so now let's plot our points. We always use this new value and this value, this new value, this new value, this value, this value, this value, this value. We always use those new values. So when we are at 0, we're going to be at, when we're at 0 for x, we're at 2. Right here at pi, I'm going to be at 5. 1, 2, 3, 4, 5. At 2 pi, we're going to be at 2. At 3 pi, oh shoot, at 2 pi, I'm going to be at 2. Here's 3 pi, I'm going to be at -1. It's right there. And then down here at 4 pi, I'm going to be at 2. Ignore that point. We'll get my lens white out. I'm looking at the x-axis on that one. Okay, so look at it again. I've got 0, 2. Here's x is 0, 2. When I'm at pi, I'm going to be at 5. When I'm at 2 pi, I'm going to be at 2. When I'm at 3 pi, I'm going to be at -1. Here's 3 pi. 3 pi, I'm going to be at -1. Sorry, my eyes aren't great. 4 pi, I'm going to be at 2. Okay, so this is the way it's going to go then. Okay, so it's going to look like that. The amplitude is always this number right here in front, so the amplitude is going to be 3. It's not a -3, that just was my pen. The domain is going to go -infinity to infinity. The range, we look at our lowest number up to our highest number. And the sinusoidal axis is always this right down the middle part, also called the midline. And that's always going to be this number right here. It's how much we shifted up or down. So that equation is going to be y equals 2. Okay? If you want to check it, you can go on to your Desmos. Put this in here. I'm at 3 sine. I go to parentheses 1/2. Arrow out of that, x. Close your parentheses, and then +2. Okay, and here's what we get. Let's just check these points right here. So if I click on it, 0, 2, it tells me that one, I had that. Pi 5, we have that one, don't we? Let's check this bottom one. 3 pi -1, do we have that in our chart? See, look at your chart. See how we have 3 pi -1, so that helps us to know that we're right. If you check on Desmos and you're not having those values in your chart, then you know you did something wrong, okay? All right, guys, I hope this makes sense. The hard ones are going to be when this is 1/2 because you have to extend this axis. If I have time, I'll go in and I'll just try to extend it for you so you don't have to do it. I'll see if I can get that done so you don't have to extend it yourself. So when you look at the worksheets, any of these that have the 1/2, I'll go ahead and do that. I'll extend the axis so that then you don't have to worry about doing that. Okay, guys, thanks a lot for watching. Hope you're doing really well. If you need any help, just let me know. Bye.